Now we're going to be looking at the we do, and we are looking at the graph of our first derivative function, first derivative of the function f of x, and with the goal of learning about our original function and our second derivative, and then graphing them. So when we're doing this, we're going to start by looking at our x-intercepts, which, remember, x-intercepts on our first derivative graph are critical points on our original graph. So we've got x-intercepts at -1. Just make that a little better. So I'm going to go ahead and put that on my original one as well. At 2. And at 5. And each of those pink points are going to be where f prime equal to 0. All right. Next, we have to look at our slope of our derivative graph, and that's going to be your second derivative. So f prime equal to 0 would be f double prime equal to 0 are going to be your critical points of the first derivative graph and inflection of your original graph. So for that, we've got, let me just color these. All right, we've got a maximum, a critical point at 0. And we've got a critical point at 3. And at each of those, remember, our second derivative is equal to 0. So let's look at the values of our first derivative. So our output values, our y values, are negative to the left of -1, positive from -1 to 2, negative from 2 to 5, and positive afterward. So the output of my f prime graph tells me the value of my f prime derivative. And then I look back at my original graph and I say, well, it's negative, so I'm decreasing, positive, so I'm increasing, negative, decreasing, positive, increasing. Then I look at my slope of f prime to draw conclusions about concavity. So I'm increasing to the left of 0, which means I'm concave up to the left of 0, and my second derivative is positive. I am decreasing between 0 and 3, so I'm concave down on my original function, and negative for my second derivative. I am increasing from from 3 to 5, so that's concave up. I neglected one of our inflection points here, so this one's both a critical point and an inflection point. Okay, so we're concave up, I'm increasing, and positive. And then after 5, we switch to concave down because our slope goes to decreasing on our f prime graph, and our second derivative is negative. We're going to use this information now to make our graphs. So, sorry about that. Our original graph is going to be decreasing until -1, and then concave up until 0. So decreasing until -1, we've got to go down until -1, and we are concave up until 0. So we need to have some variety of a minimum here, because we're decreasing it till -1, and then we're increasing, and we're concave up until 0, so we're going to put a point there. We switch to concave down, but our graph is still increasing until 2. And then we are decreasing and concave down until 3. And we're still decreasing until 5. Right? But we are now concave up. And then at 5 we switch to concave down, and we are increasing, so it's going to look kind of funky. All right. Our second derivative graph, our x-intercepts are now going to be at 0, and 3, and 5. We're positive, then negative, then positive, then negative. This is f of x, this is f double prime. All right, go ahead and try the you do.